Hello, this is Dr. Grande. Welcome to my video on graphing a moving average using Microsoft Excel. A moving average, which is also known as a rolling average, is used to display time series data in a manner that smooths out the high and low values. This is particularly useful when working with data that varies based on a cyclical pattern. So taking a look at these fictitious data I have loaded in this worksheet, I have the days of the week in column A, and there are 100 days represented here. And then in column B, I have a value that represents the number of participants available that day for a research study. And we can see just by looking at the first few days that the values vary throughout the week. So to take a look at this on a graph, I'm going to select A1 through B100. So all 100 days and all 100 values in column B. And then I'm going to go up to Insert on the ribbon up top, and then Charts, and insert a line chart. I'll make this larger and change the background color to black. So now it's a bit easier to read. So as we look at the number of participants available each day of the week throughout this time period, we can see there's a trend that emerges. On Tuesday, Wednesday, and Thursday, there tend to be a higher number of participants available for the research study, and on Saturday and Sunday, there tend to be fewer participants available for the study. So there's a cyclical pattern, and it seems to be based on a week. So in this instance, we may be most interested in a 7-day moving average. The 7-day moving average will give us an idea if we have a change in the number of participants available for the study over time. Although by looking at these daily counts, we can see that the higher values tend to be higher later on to the right here in the graph, and the lower values tend to be higher as we move to the right. So we would suspect that the rolling average will increase over time. So I'm going to delete this graph and move back to the worksheet. I have this formula displayed here in cell F2 that I'm going to put into cell C1 and autofill down. And this formula will calculate the rolling average for any number of days that's specified here in cell D2. In this case, I have it set to 7 days for a 7-day moving average. So I'll enter this formula into C1 and explain how it works. So we'll start with equal sign, and we're going to start with if error as the first function. And you can see this has two arguments: the value and then the value if there's an error. I'm putting this in place to remove the error message that will appear in the first few cells where there are not enough data points yet to construct the moving average. The formula will function without the if error function being used, but the output will not look as clean with the error message displaying in the first few cells. So for value, we're going to start with average. So we have if error and then average. And this is because we're looking for the moving average or the rolling average. If we wanted a rolling total, we could do that too. Instead of using average, we would just use sum. And then for the average function, we're going to start with offset. And the offset function has several arguments. You can see there's reference, rows, columns, and optional height and width. So I'm going to start with reference, and this is going to be cell B1. And after I select that, I'm going to press function 4, F4, to make that an absolute reference. So it won't change as I autofill this formula. The next argument is rows, and that's going to be this row number, the row number for this cell, minus the value we have in for the number of days, in this case 7. And that value is contained in cell D2. So this will be row, open parenthesis, close parenthesis, minus cell D2, and again I'm going to press F4 to make D2 an absolute reference. Then a comma to move to the next argument, and that's columns. That's going to be 0, no offset for columns. For height, this is also going to be cell D2. And again, we'll make that an absolute reference. And for width, value of 1, close parenthesis again, then a comma, and then quotation mark. So this is the value of error, so we want nothing to be displayed if we have an error, and then close parenthesis. So notice there's no value displayed there because this would normally be an error. So I'm going to autofill this down to cell C100, and we can see the 7-day rolling averages appear starting with the 7th value. So for Sunday through Friday, no value can be displayed because there need to be 7 days to get that 7-day rolling average. I'm going to create a chart that contains the original data and this new 7-day rolling average that was created here in column C, and I'll do that by selecting all of the data, so from C100 all the way through cell A1. So the day of the week, the number of participants available for the study, and the rolling average. Go up to Insert, Charts, Line Chart. I'm going to change the background to black to make it a little easier to see, and delete the chart title and the legend. And I'm going to resize it so that I can still see the days displayed here in cell D2. So again, we can see the cyclical pattern of these data in the blue line here. The blue line represents the actual data points, the number of participants available for the study, and then this red line is the 7-day rolling average. And we can see that it smooths out the highs and the lows that we see in the original data. And over time, as we can see in the graph as it moves to the right, the 7-day rolling average increases. Over here toward the middle of the graph, it was 6.57, and toward the end, the last value, 13.29. At the very beginning, it was 7.29. So what would happen if we tried out different values instead of the 7 days for the rolling average? Manipulating this value is going to change how well the rolling average smooths out the high and low values in the original data. So if I were to change the number of days to just 1, we can see that it exactly matches the actual data. There's no difference here between the rolling average and the actual values. If I move it to 2 days, you can see that the 2-day rolling average does not get quite as high as the actual data, and it does not get quite as low either. However, overall, it still looks like the original line. As we move to 3 days, the highs and lows of the rolling average aren't as extreme. Moving to 4, the highs and lows are even less extreme, and so on. Other popular types of rolling averages include the 28-day and the 30-day rolling average. I'll demonstrate a 28-day here, so I'll change this value 4 to 28. And we can see with the 28-day rolling average, we have this area to the left where there is no rolling average displayed. That's because it needs 28 days to generate the first value. Notice that this 28-day rolling average, the line here is flatter than what we saw for the 7-day. If I move back to 7-day, you can see the difference. And moving back to the 28-day, we can also see that this longer rolling average, the 28-day versus the 7-day, the 28-day is less reactive to changes in the actual data. The line only moves up or down slightly based on large changes in the actual scores. Moving back to the 7-day, we can see that the 7-day rolling average is more reactive than the 28-day. So you would pick the type of rolling average, the number of days in this example, based on what type of view you think would be most helpful in analyzing the time series data. And in this particular case, both the 7-day rolling average and the 28-day rolling average are helpful for seeing the trend. I hope you found this video on displaying a rolling average in Excel to be helpful. As always, if you have any questions or concerns, feel free to contact me. I'll be happy to assist you.